Let O be the circumcenter, G be the centroid, and O prime be the orthocenter of a triangle ABC. Now we need to verify the following. Let's begin. First, we'll try to understand the problem graphically. So we begin by considering a triangle A, B, and C. Fine. Now let's choose the midpoints of each of the sides. So let's say we have the point D, which is going to be the midpoint of the side BC. CA has the midpoint given by the point E, and AB has the side AB has the midpoint given by F. Now, through this midpoint, if we draw the perpendicular bisector, then these three bisectors are going to meet at a common point O prime, which is going to be the orthocenter of the triangle ABC. So here we have O prime D. O prime D is the perpendicular bisector of the side BC. O prime E is the perpendicular bisector of side CA, and O prime F is the perpendicular bisector of the side AB. Next, we're going to consider the altitudes of the triangle ABC. That means from vertex A, we're going to draw a perpendicular on the side BC. Let's say the altitude drawn from the vertex A meets the side BC of the triangle at D prime. Similarly, we're going to draw another altitude from the vertex B on the side CA, as well as from the vertex C on the side AB. So here we have the common point where the three altitudes bisect. So this particular point is going to be referred to as the circumcenter of the triangle. Fine. Then we also have to define the centroid of the triangle. The centroid of the triangle means if we join the point A and the midpoint of the side BC, that is going to give us the median of the triangle. So here we'll have three medians, AD, BE, and CF. So they are also going to coincide at a common point, and that's going to be the centroid of the triangle. Now, I'm going to leave this as an exercise. So if we consider the orthocenter and if we consider the circumcenter, then the centroid always divides the orthocenter and the circumcenter of a triangle in the ratio 2:1. So this is very important. This is going to help us solve this particular problem. This is one fact that we need to remember. Okay, so we begin by now defining the position vector of each of the vertices of the triangle. For this, what we'll do, let's say we consider a point P, which is going to be the origin of some coordinate system. Now, with respect to this origin P, we can define the position vector of vertex A as A vector, vertex B as B vector, and the vertex C as C vector. Now, we'll use the fact that since the centroid divides O prime G in the ratio, it divides it in the ratio 2:1 internally. Now what we can do, we can use the internal section formula. So the position vector of the centroid will be PG. So here we are defining the position vector of G with respect to the origin. So PG vector, this will be equals to, we have 2 times PO vector added to 1 times PO prime vector divided by 2 plus 1. Fine. Now, what is PG vector? Now, PG vector is simply the position vector of the centroid, and we know by definition that the position vector of the centroid in terms of the position vector of the vertices is simply going to be PA vector plus PV vector plus PC vector whole divided by 3. This will be equals to 2 times PO vector plus PO vector divided by 3. So we can factor out the 3 from both sides, and that's going to give us PA vector plus PV vector plus PC vector. This will be equals to 2 times PO vector plus PO prime vector. This is a vector. So here we have PO prime, that's a vector. Now that we have the relationship PA vector plus PV vector plus PC vector equals to 2 times PO vector plus PO prime vector. So what we'll do, we'll consider that, let's say the origin coincides with the circumcenter of the triangle. So we will make this assumption. Let let P coincide with the circumcenter O. Then in that case, all we have to do is replace this P with O. So we have OA vector plus OB vector plus OC vector equals to 2 times OO vector added to OO prime vector. Now what is OO vector? That means here we just have the null vector because the point O is coinciding with itself. Then this vector is simply going to give us a 0 or the null vector. That means we now have OA vector plus OB vector plus OC vector that will be equals to OO prime vector. So this proves the first part. So our first part is done. Now coming to the second part, what we'll do this time, we are going to let P coincide with the orthocenter. So let P coincide with the orthocenter O prime. Then in that case we can replace this P with O prime, which is going to give us O prime A vector added to O prime B vector plus O prime C vector. This will be equals to 2 times O prime O vector plus O prime vector. Now O prime vector, that's simply the null vector. That means we now have, this implies that O prime A vector added to O prime B vector plus O prime C vector. This will be simply equals to 2 times O prime O vector. And this proves the second part as well.